So, hello everyone. My name's Tim. I'm from a company called Couchbase. We're one of the sponsors of the event. And today I wanted to talk about AI use cases. So it's going to be a higher level talk. I'm going to talk a little bit about AI, a little bit about use cases, a little bit about Bedrock, show a couple kind of light demos, and we'll just take it from there. Who's Couchbase? I don't know if you've ever heard of Couchbase. Couchbase is a database platform. We're a high-end database, so very fast, very flexible. So the company was actually formed with the merger of two technologies, a caching technology based on Memcached and a document data store. So you get that flexibility of application design, agile development, but the high-speed performance of a caching. So some people say it's like speed of Redis, flexibility of Mongo. But then there's a whole bunch of additional capabilities built in, like full text search, vector search, support for time series, eventing, and a very strong mobile capability. So it's kind of all one data layer as a platform that you can use to build applications on. I'll talk more about that at the end and why that's important, but a lot of flexibility for developers as well. And we've been a very long-time AWS partner, multi-year collaboration. Our database as a service we launched on AWS, a wide variety of competencies with different affiliations and badges. We're in the App Store, marketplace, private offers, and so on. So let's talk a little bit about Bedrock. Maybe some of you are quite familiar with it, maybe not, but Bedrock is the name for AWS's Gen AI services and models, right? It's the combination of the tools that are provided and all the models that are available. A wide variety of models that are available to teams to build on top of and use. I'll talk about those a little bit more in a second. You can customize those. There's some data automation tools. And of course, it's AWS, so there's a lot of security and governance. Sorry, I'm moving, so maybe that's. There's a lot of the security, privacy, and data governance controls built into it, and supporting use cases like retrieval augmented generation, which is critical in Gen AI, and we'll talk more about that, and supporting agents, or this new version of agentic AI. So what kind of models are supported on Bedrock? Well, you can see a whole host of different models are available. There's actually more that are listed on the website as coming soon, but you can see by lots of different third parties, Amazon's own models, the Titan models, and things like DeepSeek, which was released made a lot of big splash in terms of being quite capable with a lot of lower cost savings. There's opportunities in Bedrock to do things like pre-tuning and fine-tuning, so you can make those models more aligned to your needs. That's kind of it can't be done with all the models, but some of those models allow you to do that. Data automation. There's tools in place to help bring in unstructured data, PDFs, spreadsheets, emails, that type of data. That's really important because historically, that data has been hidden in the organization, right? There's a lot of value in the organization in that data, and it's been difficult to capture and bring into applications. And so data automation helps that. So we'll show some use case about that and a little bit of a demo. And then security and privacy. So things like guardrails are set up. So these are things that will help prevent a model from outputting information that you don't want it to. And then security. So with the Bedrock models, they're in your environment, right? So your data is safe and protected. The data is moving, it's encrypted, and the data is not being used to train the model, right? So those are important things. So this talk is about use cases. So I want to present kind of several different use cases and talk about some of the sub-use cases as well. Let's talk about vector search, which is a critical aspect of Gen AI RAG. I'm going to talk a little bit about hybrid search, which is expanding beyond vector search. What about vector search or AI at the edge? How do you do that? How do you build that into applications? And then that retrieval augmented generation, whether that's just using your own corporate data or an unstructured text as well, and incorporating that. And then we'll talk about AI agents, which is kind of even more complex situation. So what is vector search? So maybe some of you are aware, but I'll kind of explain it at a high level. Essentially what you're doing is you're you're taking an object and you're making it searchable by converting it into a very large numerical value, right? Computers are very good at math and they're very good at numbers. They're not very good at actually, a visual object. But you can take text, you can take images, you can take objects, use something called an embedding model, and that does a conversion into a very large numerical array. That gets stored into a database, and then when you're building an application and you're doing a search, you can find objects that are related to each other. Similarity search, this is sometimes called. Semantic search, this is sometimes called. You're trying to find objects that are similar to the object that you have converted into embedding. So you're trying to match these things. So by finding those similarities, I can do a search for French Open, the big French tournament, and I can also say, I only want, a certain distance, or only deliver me so many results, and it will give me the nearest objects related to that, right? That's vector search at a basic level. Hybrid search is then saying, wow, we can take that power of similarity search and combine it with our traditional searches of exactness, right? When you do a query, a SQL query, you're searching for a specific number or a range of numbers. So what if in a retail scenario, I had a store, an online store, and I sell all kinds of products, and I wanted to buy shoes, right? I might want to buy shoes that are in a certain price range, have a certain rating. You want to use geospatial search. I want to find them in stores near my house, right? I have a whole bunch of other criteria. I want to search by text. I want to look for something that's fun. Great. Those are kind of more traditional. Vector search allows you to do a similar search based upon those embeddings. Well, what if I have an app that allows me to take a photo of something and also use that in my search criteria? So if I want shoes that match my cool, funky car, and my wife wants shoes that match her new polka dot blouse, the app, you take that photo, it's creating, the photo would be ingested, creating an embedding, and you're using that in your search as the similarity search, that semantic search. And so we're getting different results, but you're incorporating a new level of search. So that's kind of this idea of hybrid search. You're taking vector search and your traditional mechanisms and using them together in an application. Okay. Likewise, you can do these things at the edge. So you can build in vector search into a mobile device and have local storage of embeddings and do those things on device. So you could work with small language models or other kind of visual models at the edge. And that way, all of this work that's being done doesn't need to go back to the cloud. You can do this locally. So an example of this would be like a retailer having a shopping cart app where you're taking photos of your products and it's recognizing them and it's adding it to the basket and at doing a total. And it's basing that, it's doing that search and matching those items in the database, right? And so as an example of this, I've got a little animated GIF here of something that we had built as an example. This one is not using actual fruit. It's showing just kind of little cards of fruit, but it's the same kind of idea. So this is built on, this is within a mobile app that would work entirely offline because the search and all that, the vector search and all the application code is done locally, okay? So that's vector at the edge. Retrieval augmented generation. So this is where you're now enhancing the results that's being output by a foundation model, a large language model, with some typically your corporate information, right? So in this scenario, a user is asking a question. That question is going to be converted into an embedding as part of the process. And it's saying, what is this person looking for? Now, you could take that question and just provide it to the LLM, and it would spit you out an answer. But by taking the embedding, searching your database, and let's say now the database has, again, we would use that retail example with the clothes, you've got all your product lines. You might have embeddings of your product descriptions. You might have embeddings of the photos. You might have embeddings of the entire product itself, everything, all the details. And therefore, that question comes in, it's going to do a vector search, find some relevant items, and provide that to the LLM. So the LLM's giving you an answer that also has a lot of context and is giving you, ideally, a better answer than just, without that other corporate knowledge. So we're going to move on to the next use case, which is actually going to be then a little bit more complex. We're now going to talk about doing retrieval augmented generation, but now using unstructured data, which would be nice to capture that. So what we're looking at here is a very simple demo that one of our engineers built. And what I'm going to do is I'm browsing a file and I'm going to ingest a PDF. So here's the PDF. I'll open it up and show you the whole thing. Basically what it is, no thanks. It's like a 13-page document full of technical diagrams and technical information. And this is about our latest data storage engine in our database. So we have two. We have our older one, it was called CouchStore, our newer one called Magma, and this document is a white paper on the technical details of that. Okay, so that's what I'm going to use. And I'm going to browse, and I'm going to select it. I'm going to upload it into the database. And so it's working. And you can see now that this PDF has been loaded into the database. And what happens in that process is typically you take your object, you can break it up into smaller pieces if it's too long. And then those pieces get converted into embeddings that we use for the vector search. Okay. And then what I'm going to do, I've got a little just question here I've written in advance for time. Copy and paste. And basically what I'm asking this app, and it's going to do one as a RAG scenario and one without. Tell me the difference between the Couchbase's storage engines, one CouchStore, one Magma, and show me metrics where possible. So I'm going to run this query. What it's doing now, you can see in the corner that it's running, it's working. It's now doing those things that I showed you in the last scenario, right? It's going into the database. It's looking for the vectors based upon this question. It's taking this question, converting it into a vector, trying to find that relevant information in the database, and then working with the LLM to give me a better answer. So as I see here, I can scroll down. And this is the top one is the vector, the RAG scenario. And so it's giving me, the LLM's producing me an answer of why how they're different. But you can see in here, oh, it didn't work there. It should be, you can see here that it's pulling out different statistics from the document talking about speed. That one didn't work very well, sorry. Down below is the generic answer. So it's just giving me standard text from our website and so forth. So it's not giving me the metrics that I was asking for. So that demo, not the best, sorry, but essentially trying to show you that you can leverage this unstructured information, bring it in, and then that helps to deliver a better response. Let me go back to the presentation. We did lose a bunch of time. So what does that look like visually? So in this scenario, right, I've got my PDF example. I'm bringing it in to my application. I'm converting that into embeddings. I'm using Bedrock as the embedding model to do that. I'm storing that in the database where you can have a variety of other information as well, right, other than your vectors. And then as my question comes in, I'm using that information to enhance my answer back to the end user. Okay. So let's go on to the next scenario. The final use case that I wanted to talk about was AI agents, right? So this is kind of the more recent conversation in the generative AI world is agentic AI and this idea of agents doing things on our behalf, right? And so what are agents, right? Well, the goal is to reduce complexity, automate this stuff for us. They're semi-autonomous. The idea is that the agent is kind of like an advanced microservice that can do things on its own, help make some decisions in the data it gets and the tasks that it's doing. And it's interacting with the user in natural language and performing multiple tasks to get to the end goal. Well, how does it do this? So an agent typically has several components, mainly a bunch of tools that the developer will design. And those tools are pointing to different data sources and talking about how I can interact with those databases or the different data sources, as well as then prompts. So you might, as an engineer, define these are the types of questions that I expect that end users will ask. And if this is asked, then I will be using this particular tool to retrieve data, right? The question is, how does the agent then match up the user question with the system prompt that they define? And the answer is vector search. It's using those similarity tools to say, oh, the person asked this kind of question, I'm going to use this type of tool, right? So that's how it's doing that matching. It's gathering information, interacting with the LLM, and those interactions that happen over and over again, you want to store that information. You want to store that memory and log that in the database so that over time you can monitor these things because they will evolve and shift because of new data or maybe changes in behavior in the LLM. And so it's really important to monitor these things and change. And we'll talk about that in a second. But a real simple example here might be like a travel planner agent where I'm going in, I want to book a trip. My name is Jane today, apparently. And I'm asking questions. The agent is doing multiple tasks on my behalf to get information and might respond back to me with another question. And you go back and have a back and forth dialogue, and the agent is doing multiple steps to get to your final end goal. Okay? So wrapping up, AI is very interesting, right? I think you've probably seen lots of demos already or used it yourself in personal, but in terms of, I think, corporate applications, there's a lot of potential. But we're also know there's a lot of risk in terms of hallucinations and the ability of getting answers that might not be exactly what we want, right? So we have things like guardrails, we have safety controls, we have retrieval augmented generation to help control and deliver better answers that are more up to date and more accurate. And why is that critical? Because if you look at how we build applications in the past, it was a very static situation. You'd build an application, you might have a pick list, a drop-down, radial boxes, right? And the data is stored in a fairly structured way. You're writing queries that you're expecting a lot of exact answers. Well, in working with agents and foundation models and LLMs, we're adding a lot of variability. We're going to be asking questions in natural language, right? We're going to be including a lot more unstructured data. And LLMs are more like a black box. We don't necessarily always know what's going on. So there's a lot of variability that needs to be managed in this new world. And a lot of this data is going to be communicated and managed through JSON, right? It's the format for natural language and so on. So all of that complexity really means that you need to have your systems working smoothly together in a unified way. And so I'll kind of just leave you with this. I spoke a little bit about Couchbase at the beginning and what we do in terms of speed and flexibility, but also supporting a broad flexibility in data sets. So where Bedrock is a great AI layer to build applications on Gen AI, Couchbase in a partnership with Bedrock is an ideal data platform supporting AI applications because for all of these different components, all these different capabilities where you might be using different AI services within Amazon, you certainly can do that, but all of those capabilities are in Couchbase. So as a platform, you're getting caching, you're getting support for these different workloads, you're getting support for like time series and AI and mobile workloads and those sort of scenarios. So I just wanted to leave you with that. And with that, I will wrap up. I think we're over time given all the hiccups and everything. So thank you for your time, and I'm happy to chat with anyone about questions. So thank you.